a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. Before we review the workings of decimals, let's pause a couple of short lessons to examine the question, what are decimals and why do we write them that way? First, a decimal, is a special notation for fractions whose denominators are powers of 10. Now, do you recall what we mean by powers of 10? Recall, if you will, that a power of 10 is any number that can be written as a product of tens. So we have 4 tens being multiplied together. That's 10 to the 4th power. And that multiplication has a particular shortcut which makes it of some value. We simply write down a 1 and follow it by 4 zeros, and so forth. So refresh yourself as to what we do mean by the power of 10. We'll be using it quite a bit during this chapter. Now, if we were to put the power of tens into the denominator, 1 over 10 to the 1st or 1/10, we're going to agree to write that as 0.1. Now, this is just an agreement by people a long time ago, and it proves to be very convenient. So 1 over 10 squared, or 1 over 100, we agree to write as 0.01. And 1 over 1,000 we agree to write as 0.001, and so on. Now let's find the pattern here which might make it easier to remember. If you look at the power of 10 in the denominator, or the divisor position, count the number of zeros, 1, 2, 3, 4. Then start at this point, which we'll call the decimal point, and count over 1, 2, 3, 4, 1, 2, 3. That 4th position is where our 1 goes. This is simply an invention by our ancestors, but it proves to be very, very helpful. Without this, our calculators and computers would not have been possible. So you see how it works? This notation is really a way of writing a fraction without a fraction, in a sense. So we'll read this as 1/100th. So if I want 3 of those hundredths, I will put a 3 in that hundredths position. If I wanted a 7/100ths, I put a 7 in that position. So the important idea is that this second position here is our hundredths position for the denominator, which is always 100. Therefore, if we wanted to write this fraction using that notation, we recall that 1/10 is that first position after or to the right of the decimal point. Now, if I want 5/10 rather than 1/10, then I put the 5 in that first position, which we'll call the 10ths position. Now, generalizing that, if 1 over 1,000 was 0.001, that is the 3rd spot is the thousandth fraction, then how would we express 8 1,000ths? Well, it is that 3rd spot that we want, because it is the thousandth spot, but instead of having 1,000ths, we want 8,000ths, so we'll put an 8 there. Are you beginning to see the idea? Each of these places names a fractional denominator. The first place is the 10th place. Second place is the 100th place. Third place is the thousandth place, and so on. So as it turns out, the decimal system is an extended place value system, where now this first place to the right we'll call a 10th place, 100th place, 1000th place, 10,000th place, 100,000th place, etc. This is something that you should memorize if you have not already. Notice that word-wise, it's the TH that tells us that we are in the fractional place. So to the right of the decimal point will be the specialized powers of 10 fractions. To the left will be our traditional whole numbers. So a number like this, if we wanted to say it, this is really 5 in the tenths place, 6 in the hundredths place, 7 in the thousandths place, or 5 tenths and 6 100ths and 7 1,000ths. Or if we want to say it all as one number, we simply do this. Pretend like the decimal point isn't there and say it without it. So if we were to say that without it, that would be 567. Then say the place name of this rightmost place. So 10th, 100th, thousandths, that's a thousandth place. So now we say 567 thousandth. 567 thousandth. And the thousandth, the TH, tells me I'm in the fractional place as opposed to a whole number. Again, to get the word name from its place value name or form, say or write the number without the decimal point, then say the place value of the rightmost place. Let's try that with one more number. This form of number we call the place value name. So for this place value name, we wish to know the word name. That is, if you had to say it over the telephone, how would you say it other than, of course, 0.00107, which is the way we generally do it. Okay, we would say it without the decimal point. So without the decimal point, these front zeros are not necessary. So we would say 107. Then name the rightmost digit's place name. So 10th, 100th, 1000th, 10,000ths, 100,000ths. So 107, 100,000th. Note the TH tells me I'm in the fractional place, and the hyphen here tells me this is all one place, the 100,000th place. Again, 10th, 100th, 1000th, 10,000ths, 100,000ths. Again, to go from our word name back to the place value name, we forget this for a moment and write this, 215. 215. Now, sort of reversing our order, we want the 10,000th place. So let's just think this way. 10th, now this really isn't the 10th, but this is just a gimmick that works. 10th, 100th, thousandths, 10,000ths. So I'll need at least one place here, and then my decimal point. Now let's say it properly. 10th, 100th, thousandth, 10,000ths. So 215 10,000ths. Now some teachers would prefer to discuss it this way. Forget this and establish the 10,000th place. So there's 10th, 100th, thousandths, 10,000ths. I want 215 of them, but they must end at the end. So that forces me to put the 215 here and a 0 up here. Now, if you were to reverse that and write it this way, 215 and stick a 0 here, you wouldn't get it, because if you said this without the decimal point, you'd have 2,150 10,000ths, and this was not to be 2,150, it was to be 215 10,000ths. So this placeholder 0 must go to the front. Now the genius of this system is that the decimal form of the powers of 10 fractions, which is what we call decimals, will allow us to add, subtract, multiply, and divide with them by rules which are similar to whole number rules, which are a lot easier than the rules of fractions, which I'm sure you're convinced of after our last chapter. And as it will turn out, the decimal number combined with whole numbers allows us to treat the mixed number as though it's one number. It's a very convenient notation. It was truly an act of genius of our ancestors to have developed it. So as with the whole numbers, it's very important that you learn the place names of all of these places now to the right of the decimal point. And it always starts with tenth. It's a very important point. Make a strong note of this. We begin the first spot with tenth, then hundredth, then thousandth, then 10,000th, 100,000th, then millionth, then 10 millionth, and so on, exactly like with whole numbers, but in reverse direction, and we must start with tenth, whereas whole numbers start with 1. Very important to note that. So looking at this with our whole numbers, now see, watching this in conjunction with the whole number system, we start with ones, tens, hundreds, and move this way. With decimals, we don't start with 1, we start with tenth, then hundredth. So here's 1, then 10 tenth, 100 hundredth, thousands thousands, and so on. And as it will turn out, the decimal point we will verbalize by the word and. Okay, now this system is a very important system to have memorized, particularly those of you who will go on into computer science or math for elementary teachers, or of course mathematics in general. Now coming back and putting the decimal together with the whole number, we read it's 56 and 28 hundredths. Number like this in place value form we would write as 206, and now the decimal portion you pretend like it's not there, and that would be the number 206 again. And now we name this rightmost digits place, tenth, hundredth, thousandth, 10,000ths. So 206th, 10,000th. Again, 206, stop, and 206, 10,000th. The TH tells me I'm in the fractional spot. The hyphen tells me this is all one place. And the number that comes before it tells me how many of those places I have. 206 of those 10,000th place. Now let's reverse it, going from a place value, a word name, to the place value name. So 5,005 and. The and is a divider between the whole number and the decimal. So 5,005. 5,005. The and is a decimal point. Now let's find the place we want to stop at. 10,000th. Tenth, hundredth, thousandth, 10,000ths, and we want only 5 of those 10,000ths. So I want 5 of those 10,000ths. So these placeholders must be filled with zeros so that we don't mistake this for another place value. Okay, that's it. The beginnings of a very important number system, one of the geniuses of our civilization. Just as we hope you're beginning to realize that every mark in mathematics says something, or else we wouldn't use it, so we hope you begin to realize that that's the way it is with language 2. Notice the difference between these two just because of the insertion of this hyphen. First, we notice that each of them has THS on the end, which tells me I'm in the fractions or decimals situation. But here it says I want to go out to the thousandth place. So here's tenth, hundredth, thousandths, which means I don't even need this. And I want 100 of them. So if I want 100 to end here, I would have to write 100 thousandths, which of course as a fraction would be this, which of course we can also see reduces to 1/10. However, down here the hyphen says that I don't want the thousandth place, I want the 100,000th place. So here is my 10th, 100, 1,000, 10,000s, 100,000s. And at the 100,000th place, I want just one of them. And of course, in this case, I would have to backfill in placeholder zeros to remind myself this is down here and not somewhere else. So here I have a 100,000ths, which of course won't reduce anymore, and we see that these are entirely different numbers. This number, as a matter of fact, is 10,000 times larger than this one. Hence the importance of realizing what this hyphen is really saying, that all of this is one place, whereas here we want this as the place, and this is the number of those places. Do you see? Each mark tells us something distinctly different. And that's part of the difficulties for beginners in mathematics as well as in English composition, is that we've grown up with our spoken language, which tends to be a little bit sloppy and a little bit creative because of that, by the way. However, in the precision of technical writing and mathematics, every single mark must mean something distinctly different, or we ask, why would we use it? So be careful on the writing of these numbers. Just to illustrate the subtlety and importance in minor changes in form, let's look at these three problems two different ways. If we were to write each of these in fractional forms, we would first pretend like the decimal point isn't there, and of course that 0 in front is just for emphasis. So we have the number 457, but the decimal point says that this is a special kind of a fraction. Specifically, it's over a 1 followed by 1, 2, 3 places. Or if you wanted to say it, you would say this is 10th place, 100th place, 1,000th place, so 457 thousandths. Whereas on the next one, without the decimal point, we still have the number 457, but over a 1 followed by 1, 2, 3, 4 places. Now please note, I am not counting zeros, I am not counting numbers, I am counting decimal places starting at the decimal point. So there are 4 decimal places, hence 4 zeros following the 1 in the denominator. Or saying it verbally, this is a 10th place, 100th, 1,000th, 10,000th, so we have 457 10,000ths. And the last one we still have without the decimal point, 457. But now shortcut-wise, over a 1 followed by counting decimal places now, starting at the decimal point. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or, verbalizing it, the 10th place, hundredth, thousandth, 10,000th, 100,000th, millions. So here we have 457 millions. So to a beginner, you would look at these and just see they all have 457 and sort of feel they're all the same. And yet they are distinctly different numbers because of the different placement of that 457 in each case. And that decimal point is what helps me locate the placement. Then the zeros between the decimal point and that first non-zero digit we call placeholders. It makes sure that we're seeing this as a 10,000th place rather than a thousandth place, which we would see if we didn't have that zero. So these we call placeholders, as well as a zero in front, which is simply there for emphasis. Were we to leave the front zeros off, technically it's the same number. But we have found psychologically and visually that when we leave it off, people tend not to see the decimal point. Whereas when there is a units placeholder in front, this seems to emphasize the presence of the decimal point. So this is here for effect. These are here out of necessity. Do you see that? It's very important. And if we were to write the word name for each of these, the differences between each three representation is just as subtle. Watch this. If we want the word name for this, first we omit the decimal point and just say the number as it appears to us, 457. 457. And then we name the place of the rightmost digit. So this rightmost digit, the 7, is in the tenths, hundredths, thousandths place. So this 457 has its right end sitting in the thousandth place. And notice that the TH is what tells me I'm in the fractions place rather than the whole numbers place. Now let's do the second one and compare it with the results of the first one. We still have, without the decimal point, 457, which I wrote. But now we name the place value of the rightmost digit. So this is tenths, hundredths, thousandths, 10,000ths. So we have 457 10,000ths. Notice the THS again tells me I'm in the fractional part of my number. But the hyphen here is very important. That tells me I want to go clear to the 10,000ths place as opposed to just the thousandths place which we had above it. So again, the importance of the TH and the importance of the hyphen in our word names and in our place value names, the importance of the placeholder zeros. Now let's follow that through with our third example. Again, omitting the decimal point, we have the number 457. But now the decimal point tells me that I must name this by the n digits place. So here again we had the tenth, hundredth, thousandth, 10,000ths, 100,000ths, millionths. So we have 457 millionths, and again the importance of the THS. Okay, are you beginning to get a feel for this new kind of way of writing fractions called decimals? Of course, for most of you, it really isn't new, isn't it? We're just reviewing what you've grown up with since elementary school and now trying to really nail down subtle points that we might have missed in the past, because those subtle points are going to be all important to us as we move into more advanced uses of these decimals than perhaps you remembering counting in either elementary school or high school. And let's tie that back together with our whole numbers now at the conclusion of this lesson. If we want the place value name for this verbal statement, well, the first part simply says 206 to the and the and is going to serve verbally to tell me where the decimal point is to be. So I simply have the number 206. The and tells me to locate the decimal point. Then I have 206 10,000ths. So the TH tells me I'm in the fractional place. The hyphen tells me that all of this denotes the exact place. So finding the exact place, 10,000ths, there's a 10th place, 100, thousands, 10,000ths. So I want the number 206 to end at this spot, which tells me the 6 goes there, the 0 goes there, 2 goes there, but I still have some frontmost places that I need to hold somehow, otherwise we wouldn't know that it's there. So that's the purpose of our placeholder 0 in decimals. Just as in my whole numbers, this 0 is a placeholder, or without it I would have thought that that is 26. So without this I would think that that's 206 thousandths, and I need the placeholder here. I have a placeholder here too. That tells me I have no tens in this 206, just the 2 hundreds and a 6. So I needed placeholders in these locations to keep the numbers in the appropriate places. Are you beginning to get an appreciation for the very subtle, it's simple, the very subtle system invented by our ancestors? You will actually appreciate this so much when we begin to review addition, subtraction, multiplication, and divisions of decimals, because at that point it will allow us to treat fractions and mixed numbers as though they were whole numbers, thus simplifying a lot of work. Could you finish this lesson by giving the word name for this? Well, let's do it just talking-wise. First, up to the decimal point, that's 1007. And this says and, going to the end, again we have 1007, but we're in the fractions place, so there's tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So we have a 1007, 10 millions. So putting it all together, 1007 and 1007, 10 millions. There. Is it coming together? This is your host, Bob Fennell, until our next lesson together. Good luck.